All right, hello everybody and welcome to this session on operations of real numbers, and we will also be picking up the topic of laws of exponents. So how are we all doing today and who do we have here with us? Okay, so Prashansa, Chitra, Tatleen. All right, so we have Abhinaya here as well. Okay, hello everyone. Hi, how are you all doing today? I hope you guys have had a pretty good day. Yeah? Awesome. So Saranya is here. Sai, Sesh, Kumar. We have Chinmay. We have Zarina. Okay. So good evening to all of you. I hope you guys are all doing great. Venkat Ramana is here. Hi. Hello. I'm doing good. I hope you guys are doing great as well. Sai. I'm good, Saranya. I'm doing good today. All right. So come on, quickly let me know if I'm audible and visible by throwing a quick thumbs up in the comments box. Shankar says hi, UV says hi as well. Hi, both of you. Okay, doing good, yeah? Awesome. Okay, so Zarina has provided a thumbs up along with Tatleen and Prashansa. All right, so I'm audible and visible. So come on, let's quickly move on and check out what all concepts we are going to be covering. But by the way, you guys know this, right? Early start to class 9 and boards keeping 2023 exams in mind. These 3 chapters would be covered in a period of 45 days. We're still in number system. This would be done, and then we'll move on to polynomials and coordinate geometry after that. And the Telegram channel. Yeah, I've got to remind you to join the Telegram channel because this is where all the session updates would be posted. You will find the link to this in the descriptions box. Make sure you click that and join the channel. Okay, now during the last session, I read some of your comments and I found that students were having some doubts related to how to plot an irrational number on a number line, right? There were some doubts. So I just want to clarify those doubts first before we move on to today's topic, all right? So let me just take you through one simulation first. All right, so as you can see, this is a number line, right? I'm sure you guys can see that. So this is just something that I want to touch upon because I felt some students were not clear with this topic of plotting irrational numbers on a number line. So as you can see, this is 1 here. This length is 1. Yeah. The base, let's just call this base. This is the base, which is 1. The height is 1. So hypotenuse of this is going to be 1. But if I move it, yeah. So as you can see now, the height will remain to be 1. Okay, the height will remain to be 1, the base will remain to be 1, and when you draw an arc, the hypotenuse will become root 2, right? And then we move on. But if you observe, this pattern, even in root 3, the height is 1. Root 4, root 5, root 6, root 7, root 8, whatever you want to plot it. Okay, the height of the triangle is always going to be 1 because some of you were asking, if I want to plot root 7, what should be the combination? If I want to plot, let's say root 9, what should be the combination? Just remember the height of the triangle should always be 1. Okay, convert a third and simple form. We will be coming to that today, Bhakti. All right, and now let me just take you through this. Okay, so root 2, you have seen this, right? The base of the triangle will be 1, height will be 1, and that's how the hypotenuse becomes root 2. Root 3, you have seen it. Root 3 also, we've checked this out. Height will always be 1, the base will have to be root 2, and that's when the hypotenuse of the right angle triangle will become root 3. We're simply applying the Pythagoras theorem here, right? Cool. So how about root 4? Again, even if you want to plot root 4, which is going to be 2, this is going to be 1, this is going to be root 3, and that's how this becomes root 4, and that is 2. So just remember this. That height of the right angle triangle is always going to be 1, no matter what irrational number you are trying to plot. Even root 5. Root 5, what will you do? This will be 1, this will be 2, and then this will become root 5. Okay, I hope this is clear now. I just wanted to let you know that height of the triangle is always going to be 1. You have to keep modifying the base of the triangle in order to get whatever hypotenuse. The hypotenuse is either root 2, root 3, root 4, root 5, root 6, root 7, root 8, root 9, whatever that you desire. All right, That's it. Okay, so these were the doubts from the last session that I simply wanted to clarify first. And now let's move on to today's topic, which is going to be operations on real numbers. So let's take this first example. Good afternoon, Aditi. Crystal clear now. Okay. Saranya says, sir, for root 5, we can also take base as root 4 and height as 1. Yes, you have to take that, Saranya. That's the combination that you have to rely upon. Base will have to be root 4, which is going to be 2, and height will have to be 1. How to plot 190? 190 is a very big number. Root 190, right? Again, height has to be 1. The base has to be root 189. Okay? That's it. Cool. Come on, let's move on now. Operations on real numbers. First thing, rational, when you add it to irrational, the result is always going to be irrational. Okay? And then from rational, when you subtract irrational, it is again irrational. So when you are trying to combine any rational number with an irrational number, the result is going to be an irrational number all the time. Okay, like I will take you through some examples for these. Yeah. So first, let's check out examples for these out. Okay. Let's check out examples for all of this. Rational number is what? It can be 5, it can be 2.5, whatever. Rational number is a number that can be expressed in the form of a fraction. So let's just say 2 is a rational number. I'm adding an irrational number. This is again going to be irrational. Okay, this is going to be a non-terminating, non-recurring decimal. Another example could be 2 minus root 3. This is again going to be irrational in nature. Okay, even if you multiply a rational number like, let's say 7.5 with an irrational number like root 2, the result is again going to be irrational. And finally, when you divide a rational number like, let's say 3.5 with an irrational number like root 3, the result is always going to be irrational. You will be studying proofs for this maybe in grade 10. Right now, CERT in simple form. We're coming to that. We're coming to that. Okay. So this is something that you guys have to remember. Whatever operation you're performing between rational and irrational, okay, the result is always going to be irrational number. However, when you move on to irrational numbers, like irrational plus irrational, the result can either be rational or irrational. Like, let me just take you through this. Let's say you have root 2 plus root 2. What is this going to be? 2 root 2. And we've just learnt it. When a rational number gets multiplied by irrational, this is irrational, right? But you may also have something like 3 plus root 2 plus 3 minus root 2, right? Then what will happen? Plus root 2 minus root 2 will get cancelled and you're getting 6. So 6 is what? 6 is a rational number. Okay, so irrational plus irrational, in this case, as you can see, it is irrational, but in this case, you see it is rational. Similarly, you can try for subtraction as well, multiplication as well. Look, root 2 multiplied with root 3 is going to be root 6. So this is irrational, and this is irrational as well. But in some cases, you may have root 8 multiplied with root 2. This is going to be root 16, which we know is equal to 4, right? So now you're getting irrational multiplied with irrational as rational. So this is the reason why irrational plus minus multiply divide another irrational, the result can be rational or irrational. So these are 2 points that you have to remember. That's about it. All right, so I hope you've understood this, and we are coming to converting a CERT in the simple form. That's related to rules and exponents. So come on, let's check this out. What is this going to be? 5 plus root 3. Go ahead, type your answers in the comments box. Just tell me, is it going to be rational or is it going to be irrational? Yeah, 5 plus root 5 plus 3. What is this going to be? Root 5 plus 3. Rational or irrational? Chinmay says irrational. Very good. Prasancha also irrational. Rafiq Ahmed irrational. Saloni irrational. Okay, all of you have understood it. Why? Because this is an irrational number. You're adding a rational number to that. And we've just seen the result is always going to be irrational. I'm going to write I for irrational and R for rational. Well done. Now, what is this going to be? Root 5 plus minus root 5. The second case. Good. Answer to the first one is irrational. All of you are giving the correct answer. What about the second answer now? Root 5 plus minus root 5. Is this? Well done. Chinmay again the first to answer, followed by Saloni, Aditi, Prashansa, Zarina, Bhakti. Well done. And we have Devansh as well, Tatlin Kaur, Venkat Ramanna, Yuvi. All of you are giving the correct answer. Sai Kumar. All right. Awesome. Cool. So this is going to be what? Rational, because this will become root 5 plus and minus will make a minus. So root 5 minus root 5, this will be 0. And we all know 0 is going to be what? a rational number. And lastly, this is going to be what? Root 5 plus root 5. Root 5 plus root 5 is nothing but 2 root 5. And that's it. This is going to be irrational. We've seen that. Yes? Well done. Now let's check out subtraction. Tell me what root 5 minus 3 is going to be. So from an irrational number, you're subtracting a rational number. So well done. Answer is correct. This is going to be irrational. This will be how much? This will be rational because remember, sorry, this will be irrational as well because minus of minus will make that a plus. And root 5 plus root 5 we know is 2 root 5. And lastly, root 5 minus root 5 is 0. So this is going to be rational. Awesome. So I believe you have understood this. Yes, these rules are fairly simple and I'm sure you guys have understood these rules. Awesome. So come on, let's move on and check out the next set of operations. Okay, so let A and B be positive real numbers. So the first rule is fairly simple one, right? Because this is in the form of, I'm sure you know this, x plus y multiplied with x minus y is equal to x square minus y square. We are aware of that. If we apply the similar rule here, this is going to be root a whole square minus root b whole square. And we know this, root a, when you take the square of that, this becomes a and this becomes b. So this is one simple explanation. And this is going to be what? Again in that form, a multiplied with a is a square, minus b multiplied with this is going to be b. And these are some other rules. Root of ab under root, you can write it like root a multiplied with root b. Like square root of this can be written like square root of 3 multiplied with square root of 2. Alright, and coming to other rules, this is again a fairly simple one. Square root of 7 by 5, let's say, can be written like root 7 divided by root 5. Alright, so Zarina has a question. Root 5 multiplied with root 5 is root 25 is equal to 5, but why is it irrational? It is not irrational, Zarina, that is going to be rational because we just covered it. Irrational multiplied with irrational, sometimes it can be irrational, sometimes it can be rational as well. The example that you have given is for rational. Alright, so root 5 multiplied with root 5 is root 25, which is 5. It is not irrational. How can that be irrational? 5 is a rational number. Yes? Okay, so these are again simple rules. Last, root a plus root b whole square. This is going to be what? Root a whole square plus 2 multiplied with root a multiplied with root b plus root b whole square. I'm just using the example of x plus y whole square and I get this expansion. Okay, Asma says, how did you got root 7 by root 5? Okay, this example. Because you can use the identity. Okay, let's suppose in this root you have root 9 divided by root 3. Alright, you can write it like, you can split the root up. This can be written like root 9 divided by root 3. You can break the square root apart by giving that to the numerator and the denominator. Okay. Previous question you have written it as irrational. Please check. Okay, let me just check that one more time. I don't see that here. I don't see that here. Previous question, irrational number. Root 5 multiplied with root 5. Okay, let me just go back again. Nope, I don't see anywhere. Root 5 multiplied with root 5 is going to be rational. This was a plus here. Maybe you noticed the plus to be multiplication. Okay, so Sadhana is asking me to explain this again. Okay, let me just go through that again for you. Let's take an example, Sadhana. These are simple operations, that's all. All right, root 11 by 5, let's say, is a fraction. You've kept it inside the square root. What I'm telling you is, you can go ahead and write it like square root of 11 divided by square root of 5. That's all. Okay, this was the last example. And this one, okay, if you're asking about this one, then what does it look like? Okay, let me just take a fresh page for you to explain this out. Root a plus root b, right? I'm going to write that down here. Root a plus root b, let's say you're taking the square of that. Imagine this to look like x plus y whole square. We know the formula for x plus y whole square, right? X square plus 2xy plus y square. If we apply that here, this is going to be root a square plus 2 multiplied with root a multiplied with root b plus root b whole square, right? Root a whole square we know is a. plus this can be written like 2 root AB plus root B whole square can be written like B. That's all. If you want root 11 whole root 11 by 5, I'm sorry Asma, I couldn't understand what the comment was. Root 11, okay, look, root 11, I'm trying my best to understand what you've said here. This can be written like, yes, root 11 divided by root 11, which is going to be 1 eventually. Yes, the answer is going to be 1, like students are pointing out over there. All right, so have you understood this? Have you understood all the identities? If there are still any doubts, go ahead. Please type them out in the comments box. I'm sure all these identities are understood now. Fairly simple. Is there a concept for this? Yes, this is the first thing. Yeah. All right. So we have understood it from the comments. All right. So come on, let's go ahead and check this out now. Let's check this question out. This is going to be simple now. Look, root 4 plus root 3 plus root 4 minus root 3. How you're going to treat this, right? So this is root 4 plus root 3 plus root 4 minus root 3, right? Taking similar terms together, root 4 plus root 4 one side plus root 3 minus root 3 one side. Now root 3 minus root 3 is going to be 0. I can pretty much cancel it out. Root 4, we all know this is 2. We all know this is 2. 2 plus 2, there you go. The answer is going to be 4. Okay, so this is going to be the clean solution for it, right? The clean says answer is 1. All right, that must have been for some other question, but yeah, this is going to be fairly simple. The answer to this is going to be 4. Okay, so we are clear with it now. Yes? Why can't it be 2 as the answer? Okay, how can it be 2? You tell me that. How can it be 2? Because after simplification, root 3 minus root 3 is getting cancelled out, right? And you all know root 4 is nothing but 2. It is root 4 plus root 4, right? So 2 plus 2, you will be getting a 4. The answer can't be 2. Answer can't be 2 at all. Okay, so far, if there are any doubts, please let me know. The doubts could be anything from all the identities we've covered so far. Because I'm sure you guys know these basics like root x. When you're taking the square of that, this is going to be x. No problem if you're late. We've just got started. All right. All right. A square minus b square can be used. Yes, it will be used in some cases. All right. So come on, let's go ahead and check this problem out now. So how will we expand this? This is going to be 2 plus root 3 whole square. So I'm sure you guys know the formula. A plus b whole square is what? A square plus 2ab plus b square. Yeah, a minus b whole square formula is what? A square minus 2ab plus b square, right? Now using this formula, we are going to expand these expressions out. So 2 plus root 3 is going to be what? A square plus 2 times a times b plus b square. This is going to be the expansion for this, yeah, for this. In a similar way, let's go ahead and expand this out. So 2 square minus 2 times root 3 plus root 3 square. This is going to be the expansion for this. Now simplify this. What is this going to be? This is going to be 4 plus 4 root 3 plus 3. Root 3 whole square is going to give you 3. So this will be 7 plus 4 root 3. And what will be this? This will be 7 minus 4 root 3, right? And if you add them together, 7 plus 4 root 3 plus 7 minus 4 root 3. These two will get cancelled and you will get the answer as 7 plus 7, which is 14. Okay, if there is root squared, then there well. All right. Okay, this slide, you're talking about this slide, right? Yeah, this is clear now. Let me just give you a proper solution for this. Look, 2 plus root 3 whole square, expand it using the a plus b whole square formula. Okay, when you do that, this 4, how do you get it? This 4 is 2 plus root 3 whole square. Look, this is a square plus 2 times a times b plus b square. This is a square plus 2ab plus b square. Comparing this to a plus b whole square. So what is a? In the place of a you have 2 and in the place of b you have root 3. So in the expansion, you will substitute the same thing. In the place of a, you will substitute 2, and in the place of b, you will substitute root 3. And when you simplify this, this becomes 4 plus 2 times 2, 4. Okay, root 3 as it is. Plus root 3 whole square is going to be 3. And when you expand this out, this is going to be 7 plus 4 root 3. All right, so this expansion will give you 7 plus 4 root 3. This will give you 7 plus 4 root 3, right? Now, plus 4 root 3 minus 4 root 3 will get cancelled out. And eventually, you will get the answer as 7 plus 7, which is going to be equal to 14. A square minus b square, you cannot use it here because they are not in the form of a square minus b square. You would have used it if instead of plus, there was minus here. Then you could have used it. Okay? But there is a plus here, right? That's why. Root 3 multiplied with root 3 is 3. Yes, Aju, it is right. Some of them giving the answer as 6. No, this answer is going to be 14. We have understood that, I believe. Yes? Cool. So let's move on and check out some other things. Now we are coming to the very important topic of rationalization. So rationalization simply means you are making an irrational number into a rational number by multiplying it with conjugate. What does conjugate means? Let's suppose you have this. 1 plus 1 divided by 2 plus root 3. Now, what you are going to do is you have to make this into a rational number. So, you multiply and divide by the conjugate of that. Conjugate is going to be what? 2 minus root 3, 2 minus root 3. So, as you said, c plus d, the conjugate will be c minus d. So, just let's do an exercise in conjugate. 2 plus root 3, the conjugate will be what? 2 minus root 3. 5 plus root 7, conjugate will be 5 minus root 7. If you have 3 minus root 5, let's say 3 minus root 5, conjugate will be 3 plus root 5, like that. All right, so yes, rationalizing the denominator as it is in class 9. All right, so this is the technique for rationalizing the denominator. So in the denominator, if you have 2 plus root 3, you will multiply the numerator and denominator by 2 minus root 3. And then when you multiply these two, these will be in the form of a plus b multiplied with a minus b. And then you can use the formula of a square minus b square. Okay, so we've understood what conjugate is. Now let's go ahead and solve a question on the basis of this. Okay, so what is going to be the conjugate of 7 plus root 3? Tell me the conjugate of 7 plus root 3. The conjugate is going to be what? 7 minus root 3, right? Conjugate means, it's a difficult term to explain. Just make sure that, you understand that 7 plus means you do a minus, that's all. Okay? Something that when you multiply it, it converts into a rational number. Yes, so the conjugate is going to be 7 minus root 3. So what you will do now is, okay, let me just take you through the solution. This is this, right? The fraction. So you will multiply the numerator by 7 minus root 3, denominator also by 7 minus root 3. And now this will become the numerator. I'm sure you know how to multiply two fractions. Yeah? This will be a multiplied with c divided by b multiplied with d. And now when you multiply these two, look, this is important here. This is in the form of a plus b multiplied with a minus b, which we know is a square minus b square, right? In the place of a, you have 7 minus root 3. So this will be what? 7 square minus root 3 square. So 7 square will be what? 49 minus root 3 square will be 3. And that is how you are getting 46 in the denominator. Okay? You don't have a root symbol in the keyboard. Right. You can just say SQRT, that will be enough. All right. And then how do you simplify the numerator? 7 times 4, 28. 4 times minus root 3, minus 4 root 3. This times this times this, and when you simplify, this is going to be the correct answer. Okay, so rationalizing is a very simple concept. I'm going to give you one more example. Let's say you have 1 divided by 5 plus root 7. You will multiply numerator and denominator by what? 5 minus root 7. That's all. And then this becomes in the form of a plus b multiplied with a minus b. How did you get 46? Look, I showed you the working out here. The denominator is in the form of a plus b multiplied with a minus b. All right. A is 7, b is root 3. So the answer will be what? A square minus b square. So a square will be what? 7 square, which is 49. Root 3 square will be 3. 49 minus 3 is going to be 46. All right. I hope you've understood how we got the 46. All right, so done. Cool. Let's move on and check out the laws of exponents now. Okay, so these are going to be some laws of exponents, you know, a power m multiplied with a power n. I'm going to give you examples for each of these now. This will be what? 3 power 5 multiplied with 3 power 4, let's say. This is going to be 3 power 5 plus 4. Notice that the bases are the same, the exponents are different. All right, and any base raised to the power 0 is going to be 1 every time. Okay, now this will be what? 3 power 7 whole to the power 5, let's say. This will be 3 to the power 7 multiplied with 5, a power m whole power n. A to the power minus m, like an example could be 2 power minus 3 will be 1 by 2 to the power 3. Okay, rationalization means converting an irrational number to a rational number by multiplying with a conjugate. Okay, why can't we add 25 and 3? You can add 25 plus 3. We've added it, I believe. 25 plus 3, root 3 is there. 3 root 3 you cannot. Root 3 you have to keep it as it is. If it was 25 plus 3 you could have added it. Alright. Now these are some rules again. Notice that the bases are the same here. Again, you know, let's say 3 to the power 9 divided by 3 to the power 4. This is going to be 3 to the power 9 minus 4. Alright. And this is going to be what? Simple rule again. So you just need to remember this again. Yeah. So a to the power 1 by n. So let's say you have 4th root of 5. This can be written like 5 to the power 1 by 4. Yeah. Let's say you have cube root of 8. This can be written like 8 to the power 1 by 3. Something like this. Yes, and this root is a fairly simple, easy to understand. Bases are same. You just, you know, keep them in a single bracket and raise it to the same power. So 25 plus root 9. Yes, that you can write it because root 9, you can convert it into 3. But root 3, you cannot, because root 3 is irrational. It's going to be non-terminating and non-recurring. So that's why you have to keep it like 25 plus root 3. But if you have 25 plus root 9 gets simplified to 3, and that's how you know, you get 25 plus 3 there. Okay, Arshia. Cool. Yes, that is a cert. 8 to the power 1 by 3. That becomes what? Okay, I'm coming to that now. Let's go ahead and simplify these now. These are important simplifications. Okay, now you have to remember a few things. Like 2 power 1 is 2, 2 power 2 is 4, 2 power 3 is 8. It will help you if you memorize these things. 2 power 5 is 32, 2 power 6 is 64, 2 power 7 is 128, 2 power 8 is 56, 3 power 4 is 81, something like that. They have to be a few numbers that you will have to memorize. Most common ones are these. 27 is 3 cube, 64 is 4 cube, 125 is 5 cube, 216 is 6 cube, 343 is 7 cube. So some common cubes that, you know, unless and until you remember this, idea will not click. Okay, so 8 now can be written like what? As you've seen it, 8 can be written like 2 cube. Yes, 2 cube raised to the power 2 by 3. Yeah, now this is in the form of what? A power m whole power n. This is going to be a to the power m multiplied with n. Yeah, so now this 3 and this 3 will get cancelled. This becomes 2 to the power 2, which is going to be 4. Very simple. Okay, we'll come to that, Chitra. You don't focus on what CERT is. CERTs will come next. Just focus on understanding these basics first. Okay, they will come next. Don't worry about it. Now 27 can be written like what? 3 cube. Now 3 cube is going to be raised to the power 4 by 3. This is going to be what? 3 multiplied with 4 by 3. So this 3 gets cancelled. This is 3 power 4. When you make the calculation, this is going to be 81. All right. And then 16 can be written like what? 2 power 4. 4th root will be 1 by 4. This is going to be 2 power 4 multiplied with 1 by 4, giving you 2 power 1. So this is how you would be simplifying these things. Yep, you're getting the correct answers. Now let's go ahead and solve this question. Okay. And once we are done with this, we will move on. All right. So first thing that we're going to do is simplify this. Yeah. Now, same basis will go together. So minus 2, I'll keep it out. A power 4 divided by a. A to the power 4 divided by a is nothing but a power 1. And b square divided by b to the power 5. Now, you've just learned the formula. A power m divided by a power n is a power m minus n. So this will be minus 2 multiplied with a power 4 minus 1, b power 2 minus 5, which will become minus 2 multiplied with a cube multiplied with b power minus 3. So all of this, when you simplify, you get this. Now this will have to be multiplied with this, right? So 3a square b cube multiplied with minus 2a cube b power minus 3. So 3 multiplied with minus 2, you get a minus 6. A square a cube, this becomes 2 plus 3, and this becomes what? 3 minus 3 at the top, and that's how you get minus 6 a to the power 5, because b to the power 0 is going to be 1. We need to keep power in the up. Okay. All right, so yes, you have correct answers there, okay? So I believe you're giving the answers to the earlier questions. Now this is how you simplify things. And this is where your rules of exponents will come in handy when you want to simplify algebraic expressions like this. So all the basic rules here, a power m whole power n is a power mn. A power m divided by a power n is going to be a to the power m minus n. So that's all I'm using here. And lastly, a power m multiplied with a power n is going to be a to the power m plus n. All right. Okay, Sadhana says again, all right, let's see. All right, look, I'm first simplifying this part here. Okay, minus 2 as it is. A to the power 4 divided by a. A is nothing but a power 1. B squared divided by b power 5 comes here. Now this is in the form of what? Both of these are in the form of a power m divided by a power n, which is going to be a to the power m minus n. So if I apply the formula here, this will be a to the power 4 minus 1. And this will be b to the power 2 minus 5. And this will become what? A cube b power minus 3. So now this will be multiplied to this. Yeah. So 3 multiplied with minus 2, you get a 6. A square multiplied with a cube. A power 2 plus 3. B power 3 multiplied with b power minus 3 is b power 3 plus minus 3. And that's how you simplify this. All right. I believe this is understood, yes? And these are some identities, guys. We've already covered it. Now, the PDF file for this will be shared with you. So, the explanation for this has already been done. Okay, so you can study these out taking the PDF. Okay, so this has already been covered. All the rules are in one file, so it's easy for you to revise all the formulas. And this is one activity that you can do, right? To compare which fractions are bigger and smaller. This is going to be a fairly simple activity. Okay, so look, you can select any two fractions. Let's suppose you're trying to decide 3 by 5, 4 by 7, which is bigger. Okay, and you want to do it visually, let's say. Okay, so you can take this paper, all right, and then cut it into 5 parts. 3 by 5, you can take the second one, cut it into 7 parts and shade it. And this is how you will come to know that 3 by 5 is more than 5 by 7. 4 by 7, sorry. But then I am sure you guys are aware of a better technique. Yeah, so this is one activity that you can try it out, visual way of looking at fractions. Now I'm going to give you some homework. All right, so this is going to be good. Yeah, so check this question out and you can type out the answers in the comments box. Okay, so question is when you look at it, it may look a little challenging, but yeah, this is based on all the rules of exponents and powers. So you can type out your answers in the comments box and you can also let us know what you want to see and all of that. So I'm going to move on now. Yes, we've got you covered. And finally, your Byjus classes to teacher advantage. So on this, you will find a link to this in the descriptions box as well. You know, you've got 24/7 video lessons, personalized learning journeys. You have the dual teacher model. And then, of course, the instant doubt clarification is going to work. And finally, in case you've liked the content, hit the like button. If you feel like sharing this with your friends, please go ahead and share this out. And in case you haven't, make sure you hit the subscribe button again. All right. So that's it from my side. Previous class homework answer. I'm sorry, guys, I don't remember what the question was. Okay, we will have a look at it when we are going through another session. I'm sorry, I don't remember what the question was for the earlier session. Premium users also attend those classes. Well, you're already a premium student. You see how things work at Byjus. This is for students who are not yet premium, who can utilize that link given and try a free class out. Okay, so that's it from my side. Thank you for your time. Please practice all what you have learned today, and that's it from my side. Okay, take care. Bye-bye.